SAP HANA is a main memory-centric data management platform, running on SUSE Linux and built with C++. It can be distributed across multiple machines, offering flexibility and scalability. This presentation will explore SAP HANA's architecture, landscape, and sizing requirements, providing a comprehensive understanding for information technology professionals and database administrators. SAP HANA's speed stems from in-memory data storage, eliminating disk load times. It supports online analytical processing and online transaction processing on a single database, utilizing various in-memory processing engines. The architecture includes a calculation engine, relational database engine, and online analytical processing engine, optimizing both analytical and transactional workloads efficiently. SAP HANA's column store uses data compression techniques like dictionary and run-length encoding. When memory limits are reached, unused objects are unloaded to disk. Users can manually manage data loading and unloading, ensuring efficient memory use and performance optimization. SAP HANA server architecture includes index, preprocessor, name, statistics, and XS servers. The index server is crucial, handling SQL and MDX statements with session management, SQL processing, and a persistence layer. It ensures efficient data processing and storage, forming the backbone of SAP HANA's robust performance. The preprocessor server in SAP HANA is crucial for text analysis, extracting data during searches. The name server manages system landscape details, ensuring efficient data location tracking. Meanwhile, the statistics server gathers performance and resource data vital for monitoring system health and optimizing operations. SAP HANA's landscape integrates hardware and software for optimal performance. It leverages multi-core architecture and data compression. The system uses row and column stores to enhance data management efficiency, ensuring high-speed processing and storage capabilities. In SAP HANA, row store resembles traditional databases but leverages in-memory storage for speed. Column store, however, organizes data column-wise, enhancing read and write efficiency. The architecture includes delta and main storage, which further boost performance by optimizing data handling and compression techniques. Delta storage handles write operations with basic compression, while delta merge transfers changes to main storage, optimizing data retrieval. Main storage uses advanced compression techniques for efficient memory use. This dual storage approach enhances SAP HANA's performance, balancing write efficiency and read optimization, crucial for effective database management. Sizing in SAP HANA is crucial for determining hardware needs like RAM, CPU, and disk space. Memory is paramount, followed by CPU. SAP offers tools such as ABAP reports and QuickSizer for precise sizing calculations, ensuring optimal performance and resource allocation. SAP HANA's architecture and landscape provide substantial performance benefits. Grasping its components and sizing is vital for successful deployment. This wraps up our exploration of SAP HANA's technical facets.